In this video, we're going to look at a new topic, which is about roots of polynomials. And we're first of all going to focus on the roots of a quadratic. So if we consider a general quadratic equation, ax squared plus bx plus c, and we're thinking about when it's equal to 0, so that equation would be when we'd figure out what the roots of the quadratic are. Don't forget, a quick recap. If you have a quadratic, if it's a positive quadratic, you could have two real roots if that was your x-axis. You could have a repeated root if it touches the axis once. And you could have a quadratic like this, which would have complex roots, but they're still roots, okay? And the whole point of about this topic is essentially, we don't really care about what the roots are themselves. We're just going to label one of the roots alpha and one of the roots beta, and then we're going to look at like the relationships between the roots and the quadratic itself. Okay, so if you think about it, right, if we've got a quadratic and we know that one root is alpha and one root is beta, we could write that as x minus alpha and x minus beta. Because obviously if it's in factorized form, then the solution would be x would equal alpha and x would equal beta. So if we know one root alpha and one root beta, we could obviously write it like this. Let's expand this out and see what it looks like. So we'd get x squared minus alpha x minus beta x plus alpha beta. Okay. We can do a bit of rearranging and compare it with like the general equation for a quadratic. So if we write it like x squared minus alpha plus beta x plus alpha beta, what we've now got here is the product of the roots, and what we've got here is the sum of the roots. Now let's compare it with the general quadratic equation. If I divide the general quadratic equation by a, because notice that the coefficient of x squared for this is 1, so if we divide everything here by a, our general quadratic is x squared plus b over a x plus c over a equals 0. And now we can compare these two equations, because they're essentially the same equation, just written in a different way. One in terms of our original coefficients, and one in terms of our roots. Okay. One little tweak that we might need to make is if we could write it as x squared minus, because this is x squared minus, that would be minus b over a x, and then that we could leave that as plus c over a. So by comparing these two equations directly, we get to understand how the roots of the quadratic, alpha and beta, relate to these coefficients, a, b and c. And hopefully if we compare these two, we can see that, well, obviously, the sum of the roots, alpha plus beta, must equal minus b over a. And the product of the roots, alpha beta, must equal c over a. That there is going to underpin a lot of this topic, so it's important that we have that highlighted in our notes. Alright. A quick example before we move on. If we had 3x squared minus 6x plus 5. Now I'm not going to try and solve the equation. I don't actually care about what the original roots are, what the roots are. But if I asked you if I add the two roots together, so what would the sum of the roots be? Alpha plus beta. Without solving it, without finding the roots, I could say, well, alpha plus beta is always going to be minus b over a. So that would be minus b, which is minus 6, divided by a, which is 3. So I know that if I add the two roots together, I'm going to end up with 2. The sum of the roots will always be 2. And I know if I multiply the two roots together, alpha, beta, that will always be c over a. So that would be 5 divided by 3. So an important interpretation of this is if we know what the sum of the roots are, and we know what the product of the roots are, we can actually write down the quadratic. So the quadratic would be x squared minus the sum of the roots, which you could write as alpha plus beta, x, plus the product of the roots, which we can write as alpha beta, equals 0. So even if I didn't know what the original quadratic was, say if I said a quadratic has roots, so one of the roots was 3 and one of the roots was minus 2. If we know what our two roots are, we could quickly write down what the original quadratic was. Like the sum of the roots would be 1 and the product of the roots would be minus 6. So I know my original quadratic with these two roots would be x squared minus the sum, so minus 1x, plus the product, so plus the product, which is minus 6. Okay, so it's a nice way of us, if we know what the roots are, getting back to the quadratic. I mean, obviously for this one, if you knew what the roots were, you could write it as, well, if one of the roots is 3, you could write it as x minus 3, and if the other root is minus 2, you could write it as x plus 2, and that's another way of getting to the quadratic. But it's just about understanding how these original roots relate to the quadratic and to these coefficients. One other thing they might say, we might not know what the roots are. So say for example, if I knew there's a quadratic, but I know the sum of the roots was 2/3, and I know that the product of the roots was minus 5, I could just quickly write down what that quadratic is, even without knowing what the roots are. Okay, so it'd be x squared minus the sum of the roots, which is 2/3 x, plus the product, which is plus minus 5. So, and then as a convention, we wouldn't leave it with fraction coefficients, so you could write it as 3x squared minus 2x minus 15. Okay, so we can form the quadratic just by knowing about the actual roots, or the relationships of the roots. So a really important skill on this topic is we have to manipulate things in terms of alpha plus beta and alpha beta, because we might be given in the exam, we might be told, well, I know what the sum of the roots is and I know what the product of the roots is, but it could ask you like some other algebraic expression, for example alpha squared plus beta squared. So we need to be able to express different expressions just in terms of alpha plus beta and alpha beta, because then if we knew what the sum is and knew what the product is, we could substitute the values in. So we've got to focus on how to write things in terms of those two. For the first one, alpha squared plus beta squared, the way that we're going to do this, we could start with alpha plus beta whole squared. Now if we expand this bracket, don't forget when you square in a bracket, that there is not the same as this. Like when you square in a bracket, you don't just square the two separate terms. Think about it as two brackets multiplied together, and that would give us alpha squared plus alpha beta, so plus 2 alpha beta, and then plus beta squared. So look at what we've got on the left hand side and what we've got on the right hand side, and we're aiming to end up with alpha squared plus beta squared. The right hand side we've got alpha squared plus beta squared. So if we subtract 2 alpha betas from both sides, we know that alpha squared plus beta squared would be equivalent to this, which is in terms of alpha plus beta and alpha beta. I would recommend that you highlight this one, because that's a common one that comes up. Like they would expect you to know what alpha squared plus beta squared was as a quick rearrangement. Okay, so for the rest of the video, we're going to look at essentially more questions like this. So we've got expressions, and we're aiming to get everything in terms of the sum and the product. Possibly pause and attempt these questions but I'll be going through them in a second or two. Okay, so for part B, we've got 1 over alpha plus 1 over beta. Now we want to combine these together into a single fraction. We need the common denominator first. Oops. So if you look at your two denominators, you've got an alpha and you've got a beta. What we could realise is that we actually need them both over the denominator of alpha beta. Now what we're doing, remember how fractions work, if this one needs a beta, you've got to multiply the top and the bottom by the same thing to keep it the same. So we'll multiply the top and bottom of this one by beta. For this one, because we need an alpha, we'll multiply the top and bottom by alpha. So we'd end up with this expression. And now that we've got a common denominator, we can add. Remember, when you've got a common denominator, you just add the two tops together. And that would be now in terms of alpha plus beta and alpha beta. For the next one, let's just expand and see what happens. So if we times these two together, we'd get 4 alpha beta minus 2 alpha minus 2 beta plus 1. So we've got an alpha beta, but we're still stuck with this separate. Again, it doesn't quite look like this, does it? So all we have to do, take a factor of minus 2 out of both of these terms, and you're left with alpha plus beta. Okay. 4 alpha squared beta squared is literally just 4 alpha beta squared. You know, if both of these are squared separately, it's the same as this whole thing squared. For part E, we've got 2 fractions again. We need a common denominator before we can add them. And again, we need an alpha and a beta. So for this one, we'll multiply by beta on the top and the bottom. So that'll become beta squared. For this one, we're multiplying by alpha on the top and bottom. Now that we've got a common denominator, we can add the tops. You might think we're done, but be careful. The question says express in terms of alpha plus beta and alpha beta. So then we need to write this as alpha plus beta squared minus 2 alpha beta all divided by alpha beta. For f, we can take a factor out of both of these. Now if we take a factor of both, look what we can take out of both. Both of them have got alpha squared and beta squared in and 4. So if I take alpha squared and beta squared out of both of these terms, I would be left with alpha minus beta, which means we've got a typo on the sheet. So I'm going to have to change that. That should be plus, because then you would get plus. It's got to be in terms of alpha plus beta and alpha beta. Apologies, guys. And then finally, to finish that one off, alpha squared beta squared is alpha beta all squared. And then the very last one. Possibly pause and have a think about how to do this one if you haven't tried it already. We've got alpha cubed plus beta cubed. Think about what we did for alpha squared plus beta squared. Okay, alpha cubed plus beta cubed. We want to start with the bracket alpha plus beta all cubed, because if we expand this out, that's going to give me an alpha cubed and a beta cubed, and then we can rearrange hopefully. So have a go. Now if you've done the binomial expansion, there's a quick way of expanding this, but I'm assuming that we haven't all done that yet, so we're going to have to just expand the brackets out. It'll take us a bit of time. So if you multiply these two together first, that would give me alpha squared plus 2 alpha beta plus beta squared. and then we'll multiply everything by alpha plus beta. Alpha cubed plus alpha squared beta plus 2 alpha squared beta plus 2 alpha beta squared plus alpha beta squared plus beta cubed. Okay, so we've got, let's group them, we've got alpha cubed plus beta cubed plus 3 alpha squared betas and plus 3 alpha beta squared. And remember that all that stuff is the same as that bracket cubed. And what we're being asked about is what's alpha cubed plus beta cubed. So we need to rearrange this to figure out what alpha cubed plus beta cubed is. Alright. Subtract these terms, and then that would leave me alpha cubed plus beta cubed would be alpha plus beta cubed, and then we're subtracting those terms, so minus 3 alpha squared beta minus 3 alpha beta squared. And then just to finish off, again, remember we always want it in terms of alpha plus beta and alpha beta. Look at what we can do here. Take a factor of minus 3 out, and also take a factor of alpha beta out. Think about what you're left with. If you take the minus 3 out of both and the alpha beta out of both, you're left with alpha plus beta. Again, probably a good one to highlight in your notes this, because they can ask quite often about alpha cubed plus beta cubed, and you need to know how to express it in terms of alpha plus beta and alpha beta. Okay, thanks guys.